Assalamualaikum and hi to all my beloved audience and also to my dearest respected panels, which is Dr. Muhammad SUKRI bin Hadi and Mr. Muhammad SAIFUL Bahari bin SHAARI. Okay, wishing all you are in a good day, in a great day, okay, especially in COVID-19 situations. Okay, my name is Muhammad Mirza Azraei bin Abdul Zakir, and today I would like to present to you about my final year project entitled Dynamic Characteristics Study on a three-story buildings model through finite element analysis, which has been supervised by TS Dr. Muhammad AZHAN bin ANUAR. Okay, along this presentation, the content is introductions, problem and objective, methods, result and discussions, conclusion, and lastly is a reference. As introduction, let me give a broad idea regarding this project. Okay, every mechanicals and a civil applications have their own natural frequency, and it may excite to form a resonance. Resonance occur when the ambient frequency collide or equals to the natural frequency of an object, okay, or a system, and it causes the vibration to increase manifolds and eventually fail the system or the building. Okay, so this is the responsibility to all the engineer to avoid the resonance, whether during the designing phase or after the system was built through the vibration monitorings. Okay, the figure below shows a cases caused by the resonant effects at the Japan's Tacoma Bridge in the 1940. So, it is important to study the dynamic characteristics of a structure to avoid the catastrophic failures. Okay, the well-known tools in identifying a dynamic characteristics, or also called as a model parameters, is a model analysis method. So model analysis methods was separated into two methods, which is experimentals, which includes experimental model analysis, IMA, and operational model analysis, OMA. And the second one is a numericals through the finite element analysis. To be mentioned, this project is a continuation study from the paper titled Operational Model Analysis on a 3D scale model of a three-story aluminum structure. Okay, and these studies only emphasize on a numerical approach using a finite element analysis. So the significance of the study is to ensure the result from the experimentals, which is the OMA, and numericals was reliable. Okay. And next is a readiness toward the buildings in Malaysia for upcoming years as a safety purpose. There are some literature reviewed in the context of these studies, which are highlighted as a model analysis, finite element analysis, and a model updating. Okay, the first one is a model analysis that's stated by SP Chaphalkar. Okay, model analysis has found extensive application in civil and building structures, biomechanical problems, space structures, acoustical instruments, transportations, and the nuclear power plants, in addition to the mechanicals and aeronautics engineering. Okay, and the second one is a finite element analysis. The HB Basaga said the use of a finite element analysis as a tools to predict structural response under a static and a dynamic loads has become essentials among the researchers and the industries. Okay, and the next one is regarding to the comparative study, okay, by F. Lorenzi. Okay, he conduct the ambient vibration experiments, okay, on the 4 ancient water towers in Pompeii, and then the results was compared to the numericals methods, which is from the FE models. And lastly is a model updating. J. Bro John stated the deficiency of FE model can be rectified by making a corrections by altering some of the parameters, which is specifically known as a finite element model updating process. We proceed to the problem statement. Altogether, we have about three problem statement, and the first is the previous study has no any validation from others method, so we must find others approach to find the dynamic characteristic. And the second is there are a lot of uncertainties in the actual scale models of a three-story building model, so the comparisons need to be done between the two methods, experimentals and numerical. And lastly is the possibilities to get the right FE model is very slim, so the model updating must be performed. Literally, this project have three objectives need to be achieved. The first objective is to develop the FE models of the three-story building model using a CAD software, which is a SolidWorks. And secondly is to identify the difference between experimentals and numerical data by using the abacus and an LTES SimSolid. And lastly is to perform a model updating on the FE model of a three-story building model. We proceed to the methodology. Okay, as shown in the slide, this is the whole flow chart of the project. Okay, may I recap in short? Okay, the project will begin by gathering informations from the actual models and the previous paper, and then we develop the FE model by using a SolidWorks. Then the FE model will be run by FEA, finite element analysis. That includes two methods, which is a classicals by using abacus, and another one is adaptive methods by using an LTES SimSolid. Okay, after both method generate the dynamic characteristic numerically, okay, the result will be compared to the experimental results, okay, which is from the operational model analysis data. All right, okay, between the classicals and the adaptive method, the smallest discrepancy will be evaluated and will be used in the correlation process by using a MAC, okay, in a FEMtools software. Okay, next need to be checked whether the discrepancy is reasonable to be updated or not. Okay, if the discrepancy is exceed the 10% range, so the model updating must be take place. While if the difference was not exceed 10%, so model updating is not required. I would love to explain more deeper regarding each of the stages. So the first stage is about the gathering informations. Okay, the information found is the structure consists of 3 plates, 4 bars, and 32 brackets. And all the lowest brackets were clamped at the base. Next is aluminum was stated in the previous papers as a main materials for the structure, but not in detailed specifications. Therefore, the initial assumptions of material properties must be initiated. So this is the tables of the material properties for the aluminum and steel. In stage 2, which is a FE model development. Okay, as I said before, this model was developed by using a SolidWorks, and the overall dimensions is totally refers to the actual models. Okay, like the picture in the picture that I pointed. Okay, with the dimensions 850 mm times 250 mm times 250 mm. Okay, need to be mentioned that the models has a symmetrical shapes. Okay, so this is the side view. Okay, and the front view is this is identically same because it is symmetrical. Okay, and next bolts and nuts were merged to form a simplified part. This is because to reduce the computational time. Okay, the next stage is a stage 3, which is a finite element analysis. Okay, classicals and adaptive FEA were used as the approach to identify the model parameters. Okay, as we can see in the slide, there are adaptive methods and classical methods flowchart. Okay, so basically both methods have a same procedure, but the major difference is on the meshing process. Okay, in the adaptive method, we don't need the meshing. We don't need the meshing process. We don't need the mesh, but because we need apply the mesh as a usual FEA. So then I will explain both of the FEA methods, classical and adaptive, in a simple ways and a simple categorizations, which is pre-processor, solution, and post-processor. In Altasim Solid, during the pre-processor phases, okay, firstly, the FE models was imported into the software as a step file. Then we create the new materials by defining its Young modulus, density, and the Poisson ratios as decided before. After all the material was defined, like steel and aluminum, okay, we can assign all of those materials into each of the part in the models. Okay, so then we can define the contact conditions. Okay, as I pointed below in the figure, the red color zone is the bounded condition, is in a bounded conditions, while in the yellow region is in a sliding contact condition. Okay, the next step is by select the type of analysis, which is the model analysis, and specify the desired number of modes, which in this case 9 modes are required. Okay, so next we can apply the boundary conditions to all the bottom faces of the bracket. Okay, so select the face and assign it to be fixed as on the ground. In the solution phases, okay, we must check whether all the settings are true. Okay, so first we can see the solution settings is adapt for stiffness. Okay, and the number of modes is 9, and the constraints or the boundary conditions is immovable 1, which means was fixed on the ground. Okay, and then click the save button. Then in the post processor we can get the results in terms of displacement magnitude respect to all the natural frequency and mode shape. Alright, we go to the FEA by using an abacus, which is the classical method. Okay, as we know, the procedure is same as the adaptive methods, but in the preprocessor, classical methods have additional process, which is a meshing process. So I will touch only on the meshing process in the preprocessor, and followed by the solution and post-processor. In FEA by using an abacus, basically in the preprocessor, it have same procedure as adaptive methods that I explained before. Okay, but the major difference is on the meshing process. So this is all the part that I mesh by using abacus. So firstly, we must define its mesh controls, which is defines its mesh shapes. So this is all the shapes that I defines respective to the part. Okay, and secondly, we must define all the size, global size. So if the global size is smaller, so the computational times will be increased. Okay, and the memory use is larger. So I decided to optimize my global size as small as reasonable as possible. Okay, as we can see in the solution phases, the setting shows I use a Lancos agent solver, which has general capabilities among the others, and the maximum frequencies of interest I insert about a 300 Hz. Okay, because sometimes the mode shapes from the OMA occur at the high mode order. Okay, and lastly, in the post processes, okay, after the result was computed, about the 21 modes was generated. Okay, so after this, I will filter all the modes referred to the experimental data. We proceed to the stage 4, which is a dynamic characteristic comparisons. Okay, all the mode shapes were evaluated and matched with the experimental data. Okay, after each mode shape requires its respective pairs, okay, the natural frequencies of each mode will be compared in terms of discrepancy. So below is the discrepancies equations, and this is how we match the mode. Okay, just consider the physical shapes only. Alright, after I identified and evaluated the smallest discrepancies, whether using by adaptive or the classical methods of FEA, okay, the result will be used in the correlation process in the stage 5, okay, by using a MAC. Okay, what is the MAC? MAC is a statistical indicator that is more sensitive to large difference and relatively insensitive to small difference in mode shapes. It's bounded between 0 and 1, with the 1 is indicating a fully consistent mode shapes, while the 0 indicates that the modes are not consistent. Okay, it can only indicate the consistencies and does not indicate the validities or orthogonality. Okay, this model criterion values was generated by the FEM tools. So finally, this is the last method is the methodology, which is in stage 6, model updating. Okay, aluminum was selected as updated parameters. Okay, and then aluminum will be altered within the range of aluminum Young modulus. As I stated, the lowest Young modulus is a 65 GPa and highest Young modulus is a 72.4 GPa. Okay, it is also an effort to check the relativity of a steel stiffness against the models. Okay, the percentage of reductions will be gaps about the 5% between the unclamped zones and the clamped zone. Okay, and to be emphasized that the result from the relativity is not involved in the updating result. Here we go to the result and discussion. This is the mode shape pairing result. Okay, altogether we have about 9 experimental mode shape generated by the OMA FDD. Okay, FDD is the algorithm used. All right. Okay, so we have a mode shape generated by FEA from the abacus and SimSolid. Okay, as we can see, all the mode generated by Altium Solid was well arranged, similar to the OMA FDD mode. Okay, however, mode generated by the FEA abacus have some shifted in sequence. Okay, during the complex modes. Okay, as examples in the mode shape 2 and 1 from the FEA abacus was inverse from the OMA FDD. Okay, to make the comparisons practical, the order of a mode in the abacus was adjusted referring to the OMA FDD. Okay, as examples, mode 2 in FEA abacus was changed to 1 to make it same to the OMA FDD result. So this is on how the mode shape was paired. Alright, okay. The mode was paired based on the physical shape regardless the natural frequency. Okay. Also, the axis should be in this alike and aligned. Okay. As we can see, all the axes is the same. Okay. This is to make sure the motions and the directions of the shapes was in same pace. So the next is on the natural frequency comparison result. Okay, figure below shows the comparison result for both classicals and adaptive natural frequency from the FEA against the OMA FDD. Okay, as we can see, the figure below shows the natural frequency generated by FEA because computes about the average discrepancies, which is a 16.737%, while the natural frequency discrepancy computed by the FEA Altium Solid with an average 57.185%. So the least percentage of error will be used for a correlation process, and this case the mode shape, the resulting mode shape from the FEA abacus will be used as a correlation process. The third result is on a correlation process. Both OMA and FEA methods shows an excellent correlations through the modes 1, 3, 4, 5, 6, 7, and 9. Okay, with the MAC values between 0.8 and to 1, while modes 2 and 8 possess less degrees of consistency with the MAC values between 0.6 to 0.8. Okay, let's see to the matrix representation. All right, okay, so the bars with a reddish orange color possess consistency up to 8 40%, while the green and the yellow one is with the less consistency. Okay, and then matrix was automated arrange the mode shapes from the raw data. Therefore, this metric representation can be used as a indicator for mode pairing validation. For the fourth results is on a model updating. Okay, the significant error reductions was observed on mode 7, which is about 4.547%. Okay, we can see on these tables from a 6.765%, it reduced to 2.218%. Okay, only mode 1 shows an increasing percentage of error, which is from a 3.488% to 8.538%. Okay, this is possible because the reduction cannot be performed since it was occur at a complex mode, cannot be performed simultaneously. Okay, as a result, the updating process has managed to reduce in average about 2.927% using a selected parameters. Okay, as we can see, the average error was reduced from 16.737% to 13.81%. Okay, the selected parameters is aluminum Young modulus. Okay, this is due to the aluminum Young modulus was increased by 10% from the initial value. The last result is to check the steel relativity on 3-story building models, and this is only to portray the dependencies of a steel stiffness on the whole model. Okay, and will not affect the final result. Okay, as we can see, the discrepancy was reduced when the steel stiffness was decreased throughout 10 tests. Okay, from 57.185% to 56.459%, and this was calculated by the Altesium solid, which is by using an adaptive method. As a conclusion of the study, the first and the second objective was fully achieved, since the results of a dynamic characteristics of a 3-story building model was successfully computed and interpreted numerically through FEA. Also, the last objective, which is the third objective, also was achieved since the models was updated by the selected parameters, and it shows the material used by the previous study is basically close to 2024 aluminum alloy and cast aluminum alloy 356.0. Okay, the Young modulus of the updated stiffness is 72.05, which is between 72 GPa and 73 GPa. Okay, next we also can be conclude that the classicals and adaptive methods in FEA had produced a wide gaps of average with a natural frequency value about 40.4%. And lastly, the various factors lead to the inaccuracies of a dynamic characteristics when it was tested using FEA approach, especially during assignments of boundary conditions, method properties, the geometries, number of meshes, and the type of joint. So finally, as a recommendations for this study, first, the study must focus the modification on both connections as well as forming an actual connections model without any simplification. Okay, next, perform a sensitivity analysis to determine the parameters that are most influential to the dynamic characteristics of the FE models. Thirdly, is update with the various parameters simultaneously like aluminum and steels at the one time. Okay, lastly, compare with the multiples of a commercial FEA tools to validate and to get the reliable dynamic characteristic. And finally, the last sections is reference. I include all the reference that I use related to this slide. Okay, that's all from me. Thank you very much for lending me your ears, and I hope this presentation give a clear understanding about the whole of the projects. And no worries, if there are any inquiries or any questions, just contact me through my emails and my phone number stated in this slide. Once again, thank you very much.